Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, grade 6. This is the second session in our lesson this week about what is the electromagnetic spectrum. Yesterday, we have explained and recognized the concept of electromagnetic spectrum. And also, we mentioned the components of electromagnetic spectrum and the way to arrange them. Today, we are going to continue. I will remind you by some information. Okay? We said what waves are included in the electromagnetic spectrum, and we said the electromagnetic spectrum includes radio waves, infrared waves, visible light, ultraviolet rays, X-rays, and gamma rays. Also yesterday we said we give a short definition of electromagnetic waves spectrum, and we said the full range of frequencies of electromagnetic radiation is called the electromagnetic spectrum. And we said visible light is a part. Yes, it's a part of the electromagnetic spectrum. It's a very small part. And we characterize or arrange them based on their wavelength and frequency, because they are different in the wavelength and frequency, while the speed is the same, as you know. What we are going to complete today. And we said about what is the electromagnetic spectrum. We said the electromagnetic spectrum is the complete range. This is another definition. You can use your words to express the right definition. It's a complete range of electromagnetic waves placed in order. What in order? From left to right based on their frequency. And we speak about this notation. We will not speak about it again. Then we explain this, some uses of electromagnetic spectrum components. Do you remember that? I would like you to memorize this from your book. You will find it in your book, and you can memorize it. And you asked some question about which electromagnetic wave have the shortest wavelengths, and you said gamma rays. Also, which one have the lowest frequency, and the answer was radio waves. Moving to the next slide. This explains the total pattern of arrangement of the electromagnetic spectrum, starting by radio waves, followed by microwave. And we said, we are speaking about two things, wavelengths and frequency. As we move from left to right, the wavelength decrease. You see, this is called from crest to crest wavelengths. Then the wavelengths become decreased, become shorter and shorter and shorter. The shortest wavelengths will be for gamma rays, while the highest frequency means the number of waves. Here we have only one wave, two waves, three waves, and by moving to right, the number of waves or the frequency become high or increase. So gamma rays have the highest frequency and lowest or shortest wavelengths, while radio wave have the longest wavelengths but the lowest frequency. Also yesterday, today we are going to start to speak about how are radio waves used. Radio wave is the first one in the pattern from left. Radio wave has the shortest or the lowest frequency, while have the longest wavelength. Radio waves are used in radio and television technologies, as well as in microwave oven. Microwave, here we are going to classify it as different because they have different frequency and different wavelengths of radio waves. Okay. Radio waves. Radio waves have the longest wavelengths, as we said, in the electromagnetic spectrum. I'll give you an idea about the wavelengths. Wavelengths range from 1 millimeter to as much as thousands of kilometers or longer. Radio waves also have the lowest frequencies. I don't ask you or request, you are not requested to memorize this number. These numbers is just for illustration. Okay, the megahertz is a unit, and the megahertz is like megabytes, which we are using in computing. In a radio studio, sound is changed into electronic signals. These electronic signals that are coded onto radio waves and then broadcast, then sent outside. Your radio is a receiver that receives the signals, electronic signals. Then this radio decodes it again to change it back into sound waves you can hear. There are two ways that signals are encoded. Encoded means send, change it from sound to electronic waves and then send. By changing in amplitude modulation, by modifying the amplitude or modifying the frequency. This is also just for illustration to know how can a radio station broadcast a sound of someone, but we can retrieve it on our radio wireless or on our mobile. They modify the sound by using two ways. Number one, modifying the amplitude or modifying the frequency. Radio wave. The announcer, the man who is speaking in the radio station, voice and the music in a CD, leaves the radio studio as electronic signals. Those signals are used to produce a wave with either a varying amplitude or varying frequency. We can give it AM or FM. If you choose your mobile or your radio, you'll find that AM waves have a varying amplitude, while FM, depending on modifying the frequency, so it have a varying frequency. So today you understand the difference between the AM and FM, both using radio waves, but one of them modify the amplitude and FM modify the frequency. This is amplitude modulation. Do you see how the amplitude modeled with this frequency modulation? Now you can change the frequency. Radio wave. FM radio signals don't travel as far as AM signals along Earth's curve. So if you are going to send radio signals for a long distance, you cannot use FM, but you are going to use AM. Right? This is only for to understand. And now television. Television also use the radio waves also carry signals for television programming. The radio waves carry information for pictures as well as for sound. Location and weather can affect the reception of television signals by an antenna. Antenna is the thing we put over the dish what are used over our houses to collect the signals. With satellite transmission, TV broadcasts are sent to satellites, which then retransmit the signals back to Earth. Signals can go to home satellite receivers or to cable service that receive the signals and send them through cables. This is some information about it, how to grab, but we don't need it. It's just for illustration. Now the second thing is microwave. All of us has microwave at home. The microwave is the shortest wavelength after radio waves. They are called microwaves because microwave wavelengths are from about 1 millimeter to 1 meter to 1 millimeter. So the microwave is used at home to cook and reheat food. Microwave also carry cell phone conversation. It can be used. The process works much like a radio broadcast. So microwave is a type or the second type of spectrum. Microwave have the higher frequency than radio but shortest wavelengths of radio waves. Microwave used at home in cooking and it can be used also to reheat food or for broadcast. Also radar. The word radar is an acronym for radio, detection and ranging. We take radio, RA, D from detection, A and ranging. Radar technology uses a radio transmitter to send out short bursts of radio waves. The waves reflect off the object they encounter and bounce back towards where they came from. The returning waves are then picked up by a radio receiver, so we can determine the speed of a car. This is the device that we spoke about last session. A speed monitoring trailer uses radar measure to speed of an approaching car. This car is coming towards him. Number 3, infrared rays. How are infrared rays used? Infrared rays are used as a source of heat and to discover areas of heat differences. Infrared rays have higher frequencies than radio waves and lower frequencies than red light. Red light is the first light of the visible light. Infrared wavelengths vary from about 1 millimeter to about 750 nanometers. Your skin senses infrared radiation as warmth. Restaurants use infrared lamps, which give this heat light or red light, keep food warm. Infrared rays, warmer objects give off more infrared radiation than cooler objects. A device called a thermograph used infrared sensor to create a thermograms. What is thermograms? Color-coded picture that show variation in temperature. So we use the visible light to make photographs, okay, to make picture and to see. But we can use infrared rays using a device called thermograph. This thermograph device will produce thermograms. The thermograms is a picture, but it's a picture based on temperature or showing the variation in temperature. Search and rescue teams use infrared cameras to locate people who are trapped during disasters. If there is a disaster and someone trapped under a building, we cannot see him. So what we can do, using this infrared rays, using a thermograph, we can see the man because he is much hotter than the building itself. A thermograph can use to diagnose problems in a utility line when viewed in a visible light. The wires all look the same. See, this part, it has a higher temperature. It means there is a problem in this part. So we can see the cables inside walls or the cables that between posts and pillars to know which one broken or which one has a problem. Now visible light. How is visible light used? People use visible light to see, to keep, or to help keep them safe and to communicate with one another. Now we are using visible light to see them on this device. To attend these classes, we are using visible light. The visible part of the electromagnetic spectrum only is light. So all of the electromagnetic spectrum are invisible except the light is visible. That the human eye can see each wavelength in the visible spectrum corresponds to specific frequency and has a picture color. So our eyes distinguish only the frequency between the components of visible light. Visible light made up of red, orange, yellow, green, blue, and violet. Okay, you should memorize them. This number about wavelengths and frequency, you just understand which one have a higher frequency. If we start, this is starting from left to right. So the violet has the highest frequency, red has the lowest frequency, right? Red have the long wavelengths, while violet have the shortest wavelengths. By this, we come to the end of our session today, and we are going to complete tomorrow, inshallah.